Okay, love this. These are excellent, excellent questions. So we're again dealing with the hinge theorem. We need to have two sides that are congruent on both triangles. You can see a top triangle and a bottom triangle on number 13. They are reflexively, well, this side is reflexively congruent to itself. They share that side. Additionally, we've got this side congruent to this side. So for both of these triangles, we know something about the angle in between them, and we can compare them. And we can say this. We can say a couple of things. In fact, we're going to have to make two statements to get the numbers on either side of our range. So the first thing that we can say is that 28 here is across from a side that's 12, and this expression, 2y minus 7, is across from 11. So since this side's smaller, that means this angle is smaller. So how are we going to write that? We're going to write that as 2y minus 7 has to be less than the other angle of 28. And if we solve that out, plus 7, we get 2y is less than 35, or y is less than 17.5. Okay, that's the first part. And I probably could have written that smaller so I had a little bit more room, but c'est la vie. Now, we also know this, and this is just should be intuitive. We know that what's the low, so we know what the upper end of it is. Y, that value of y has to be less than 17.5. But we also know that the whole expression, 2y minus 7, there's got to be a positive, that's got to be equal to a positive angle. 2y minus 7 can't equal something negative. So we got to say 2y minus 7 has to be greater than 0. We can't have an angle of 0 in here. That wouldn't give us any length over here. But we don't know what it is. We just got to say whatever it is, it's got to be greater than 0. And once we know that, then we can solve for y. And how do we do it? We say plus 7, 2y is greater than 7, dividing both sides by 2. We get y is greater than 3.5, 0.5 there. So how do we write that then as an inequality? We would say y is greater than 3.5, and it is less than 17.5. Because remember, angles have to be greater than 0, and that's the idea here. So draw this line to separate these, and let's do the same thing again. Let's check out what we can do here. Okay, we have this side the same on both. We have this side congruent, I should say. We're measuring the same on both. And what do we know? Well, we have this side's equal to 15, and this side's only equal to 14. So that means that this angle 50 has to be bigger than this expression 4x minus 10. So we can write it as such. We can say 4x minus 10 we know is going to be less than 50 degrees because the opposite side is less than the side that's opposite of the 50 degrees. And then we just solve it. We say plus 10, 4x is less than 60, and we divide that by 4, and we get x is less than 15. That's part of it, but we know this other bit too, which is that this angle here, whatever it measures, it's got to be greater than 0. Okay, got to be greater than 0. So if that's the case, then we can set it equal to greater than 0. We can set, or not set it equal to, but we can set up the inequality as 4x minus 10 has to be greater than 0. And then when you solve it, plus 10, forgive the sloppiness, 4x is greater than 10. And when we divide both sides by 4, we get x is greater than 2.5. So we can write the final inequality as x is going to be greater than something, less than something else. It's greater than, in red, it's greater than 2.5. And it's less than, over here in blue, it's less than 15. Just to be clear, that's 2.5. So there's our inequality. The big idea here is if some variable expression is across from a smaller side, it's going to have to be less than the angle that's across from the side larger than it. And of course, the whole expression has to be greater than 0 because if it's giving you an angle measure, you can have negative or 0 angle measures and have any length over here. So we would set that greater than 0 and solve it all out. That's what we did. Ask me the questions if you have. Hopefully that makes sense to you. A little bit challenging. I think you can do it. It's just about the thought problem of what am I comparing to? How do I set up that original inequality like this and like this before I solve it? I think the algebra itself is easy. Just got to set it up right. Good luck.